My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 312. Please turn to it. Page number 312, and today is our lesson number 29. Let's take a look at the very first problem on the page. Problem number 35. We are told that we have a cargo ship which is 4.2 miles from a lighthouse. Alright, let's see what the question is actually asking. The question is asking what is the approximate distance between the cargo ship and the fishing boat. Now pay attention to the fact that we are being asked to find the approximate answer. So we won't have to do the exact calculation. So here's the picture. Here's our cargo ship. Here's our fishing boat. And we are told that the distance from the cargo ship to the lighthouse, here's our lighthouse here. This distance is 4.2. We are also told that the distance from and the fishing boat is 5 miles. The distance from the lighthouse to the fishing boat is 5 miles. They go on to tell us that the straight line, if you were to make a straight line, it says the angle between the straight line from the lighthouse to the two vessels is 5 degrees. In other words, if you were to make a straight line from the cargo ship to a lighthouse, like we just did, and if you were to make a straight line from fishing boat to lighthouse, then the angle that we will get in between is 5 degrees. And the question simply is, what is this distance between the cargo ship and the fishing boat? This distance is what we're looking for. And then they go on to give us a formula. It's a very straightforward, simple question because they're actually nice enough to give us the formula that we need to employ to figure out the distance that we are interested in, which is this distance between the cargo ship and the fishing boat. And the formula that they give us is this. C squared, pay attention, is a small c squared, is equal to a squared plus b squared minus 2 times ab times cosine of c. Now the thing to keep in mind here, the thing to realize is that because the formula is given to us here, it is up to us to be smart enough to use this formula in such a way that we don't have to modify it. In other words, we should label our triangle in such a way that corresponds to this formula right away. This says c is equal to c squared is equal to this part. C is the unknown quantity that we are interested in. Let's put it here. Okay, watch what happens. So here's our triangle. If you're going to call this distance c, then the vertex facing the c right here, that has to be point C. So lighthouse has to be point C. And then just name the other two, A and B. It doesn't matter what you call the other two, but I'm going to go in alphabetical order, A, B, and C. In other words, I'm going to go in a clockwise direction. We could have called this one A and this one B, but then we would have to go anti-clockwise or counterclockwise, as you call it. I don't like going counterclockwise, so let's call this one A. Let's call this point A and this point B. If you're going to call this point A, then the side facing this point is going to be A, and this is point B. The side facing this one is going to be B. That's all. So B in our case is 4.2. This is our B. And C in A in our case is 5. That's it, we are done. All we have to do is put in the value and we are done. So C squared is equal to A squared, which is 5 squared, plus B squared, which is 4.2 squared. But like I said, it doesn't matter. It doesn't matter which one you call A and which one you call B, for one very straightforward reason, because in the formula these two quantities are being added. So if these two quantities are being added, the order doesn't matter whether it's a squared plus b squared or b squared plus a squared. In other words, whether we have 5 squared plus 4.2 squared or 4.2 squared plus 5 squared, it's not going to change anything. Second place where a and b appear is where they appear as a product, a times b. Again, because they are being multiplied, it doesn't matter which one you call a and which one you call b, because 5 times 4.2 is same as 4.2 times 5. So it doesn't matter which one is a or b. So 5 squared plus 4.2 squared minus 2 times a, which is 5, times 4.2 times cosine of 5 degrees. That's it. That's our answer. This is our answer. And of course, in order to figure out the c, we need the whole thing in the square root sign, which will do it. But the point is that the correct answer, whatever it is, must contain cosine of 5 degrees. And if you look at the answer choices, anything that does not say cosine of 5 degrees is wrong. In answer choice D and E, they have cosine of 85 degrees, so that's no good. In answer choice A, cosine doesn't appear at all. It's either B or C. And the only difference between B and C is that in B, we are given a negative, in C, we are given a positive. In the formula, we have negative here. 5 squared plus 4.2 squared minus, we have to have a minus. Minus, and that minus appears in B. The answer is B, not C. The only difference between B and C is that one contains negative 2 times 5 times 4.2 cosine of 5 degrees, and the other one is positive. You have to pay very close attention, otherwise there's a chance that you might end up making careless mistake. You understand? That's the only difference. Let's move on to number 36, shall we? That's it, we're done with this one. Number 36. In number 36, we are asked to express C in terms of A. And A squared, we are told, is equals to B, and C, we are told, is equal to B squared. Well, if you have to express C in terms of A, here the C is being expressed in terms of B, we have to replace this B with A by using this equation. Here we have B squared, somehow we have to get a B squared here, which is very easy. How do we get a B squared here? Something is wrong. I don't think I wrote it right here. It says A cubed. A cubed. So how do we get a B squared here? Because I remember I didn't remember seeing B squared in both of them. That's how I caught myself. How do we get a B squared here? Well, it's very simple. You square both sides. You square this side and square that side. So now we have B squared, and A to the third power squared is A times A raised to 3 times 2, which is B squared is equal to A to the 6th. So we know now B squared is A to the 6th. We put it right in here, which means C equals B squared, which is A to the 6th. That's it. C equals A to the 6th. Very simple, very straightforward. The answer is F. Let's move on then to the last one. Number 37. In number 37 it says, which of the following is not true? Which is not true? Regarding the arithmetic series that is given to us. Now, before we go any further, do we understand what it means to have an arithmetic series or arithmetic sequence? What does it mean when we say that we have an arithmetic sequence or arithmetic series? Arithmetic series is one where each two consecutive numbers, their difference is always the constant. Their difference is always the constant. Two consecutive numbers have the same difference as you go along in the series. For example, here we have 17. 17 minus 5 is 12. And then we have 12 minus 5, which is 7. And then we have 7 minus 5, which we are told is 2. So what do you suppose is going to be the next one? The next one is very simple. It's going to be 2 minus 5, which is negative 3, and so on and so forth. It's an arithmetic series. It's an arithmetic series because the difference is always constant. From 17 to 12 is a difference of 5. It goes down by 5. From 12 to 7 is again it goes down by 5. 7 minus 2 is again 7 minus 5 is 2, and so on and so forth. It's an arithmetic series with the common difference of 5. With the common difference of 5. This is called the common difference. The common difference. To be more precise, the common difference is not 5. The common difference is negative 5 because it's actually going down, not up. Had it been going up by 5, we would have said the common difference is 5. Let's look at the answer choices, shall we? Enough of the talk. The first answer choice says the fifth term is negative 3. Oh, fifth term is negative 3. We just found it. Fifth term is negative 3. This was 1, 2, 3, 4, and that's the fifth term. And that is negative 3, so that is correct. Answer choice B says the sum of the first 5 terms is 35. Let's find out if it is 35 or not. If it is 35, then that's not the answer because we're looking for something that's not true. We're looking for something that's not true. If it turns out that the sum of the first 5 terms is not 35, then we're done. Then the answer is B. Let's find out, shall we? So we have 12. Then we have 7. Oh, we have 17 in the beginning, sorry. The first term is 17. The story begins from here. 17, 12, 7, 2, and negative 3. Let's see what we can do. Let's see what we can do. 7 plus 2 is 9. 7 plus 2 is 9. 9 plus 9 is 18. That's 9. That's 9. 9 plus 9 is 18. 18 minus 3 is going to be 15. So that's a 5. Carry 1. 1, 2, 3. Oh, it is 35. What do you know? The sum is 35. They're going to make us work. The answer is not B because B turns out to be true. Let's look at answer choice C. C says the 8th term is negative 18. We're going to have to figure out the 8th term. Eighth term is negative 18, and at the very end of the problem, I'm going to tell you that we didn't actually have to do any of this work at all in this particular problem. We didn't have to do any of this work at all had we done this question in a smart way, which we are not right now. We are not doing this. We are not looking at this question in a very smart way. We are doing this problem in a very academic way, very classical way, in a very orthodox way, in a very geeky, very nerdy, very academic way. That's not how we take the exam. I'm going to show you the quick way in a second at the very end, after we have suffered. Let's continue. 8th term is negative 18. As you can see, it's taking time. The 5th term is negative 3. So the 6th is going to be negative 3 minus a 5, which is going to give us negative 8. Negative 8. The 7th one is going to be negative 8 minus a 3, which is negative 11. And the 8th term is going to be negative 11 minus a 3, which is negative 14. Is that what it says? It says negative 18. 8th term. Did I make a mistake? It says the 8th term is negative 18. Oh, I lost it. 1, 2, 3, 4, 5, 6, 7, and 8. That is the 8th term. Negative 3 minus a 5. The common difference was 5, so negative 5. So negative 8, negative 11, negative 14. 8th term is negative 14. It says 8th term is negative 18. I know the answer is not C, that's why I'm hesitating. What am I making mistake here? 5, 5, 5, 5, negative 8, negative 11, 6, 7, 8. Negative 11 and negative 3 is going to be, oh Jesus, why are we subtracting 3's? This is how you make careless mistakes. This is how you blow your score in the exam. Why am I subtracting 3 each time? We subtracted 5. The common difference is 5. The common difference is 5. And all of this is coming into play because I already know what the right answer is, and I'll tell you at the very end how I know the right answer. You see how this is not how I did this is how we learn how to take the exam. Not only it takes a tremendous amount of time, but there is a lot of chance that you're going to end up making some careless mistake because you're so bogged down in doing the calculation. Don't do it this way. My having made a mistake actually teaches us a lesson that this wasn't the right way to do, because first of all it takes a lot of time, and secondly there is a very high chance of ending up making some careless mistake. Now had I not known from the very beginning what the right answer was, I probably would have picked this answer. Because I'm coming up with negative 14, this one says the 8th term is negative 18. I'm coming up with negative 14. The reason we are coming up with negative 14 is because for some strange and inexplicable reason, I don't know what possessed me, all of a sudden I started subtracting 3. Why am I subtracting 3? The common difference is 5. What the hell? We have to subtract 5. 8 minus 5. 8 minus 5 is going to be negative 13. And negative 13 minus a 5 is going to be negative 18. So that is the correct statement. Answer is not C, which I knew, as I told you before, all along. It's not. D says this part. This is D. D says that the common difference is 5, which is correct. Now here's the question. How would we go about doing this problem in the real exam? Would we do it this way? The answer is no, obviously, because as you can see, there is too many chances of making careless mistake, and it's a very time-consuming process. You have to browse through the answer choices very quickly. Whenever they tell you which of the following is not true, take a very quick look, a very quick browse through it, and see if there is one odd man that stands out. That's what we're looking for. We're looking for an odd man out, something that is not true. If you look at the answer choice E, it says, it doesn't say common difference. It says common ratio. It says common ratio. There is no such thing. Listen very carefully. There is no such thing as a common ratio when one is dealing with an arithmetic sequence. Common ratios only pertain with geometric series. Common ratios deal with geometric series. We are not dealing with geometric series. Right from the very beginning, we were told that this problem deals with the arithmetic series. In arithmetic series, what we talk about is a common difference. The numbers go up by constant amount. They go up or go down by a constant amount. There is no such thing. They don't go up and down in certain ratio. They do not go up and down in certain ratio. They go up by absolute difference, either up by 5 units or down by 5 units or up by 7 units. Whatever it is, the difference is constant, which is why it's called the common difference. There is no such thing as a common ratio when one is dealing with an arithmetic series. So when I saw the word common difference in the answer choice E, as I was browsing through it without having done any work at all, when I was browsing through the answer choices, this guy stood out. There is no such thing as a common ratio. We don't even have to bother reading the rest of the answer choice. We don't have to worry about what it says in the end. It doesn't matter. It doesn't matter what it says after that. There is no such thing as a common ratio when one is dealing with an arithmetic sequence. That is wrong. Answer is E. That's the statement that is not true. It is not true because such a thing does not exist. It is not true because such a thing does not exist when one is dealing with an arithmetic sequence. Do you understand? I'll see you tomorrow, okay? Bye now.